lesson focuses on the graphing a quadratic function in factored form. This first slide, what I do want you to write down is what does it look like when a quadratic function is in factored form. You're going to see parentheses, multiple parentheses, and we want to find out first what are the x-intercepts. So that's step 1. And then step 2, we don't need to write any of these steps down. We'll convert it to standard form, then do steps 1 through 3 and 5 of standard form, and then graph it. So this slide, I would write down everything that I talk about in this. It's an important slide. So what we have is a function f of x equals negative, and then parentheses x plus 3, parentheses x minus 1. So step 1, it's already factored out. So we're going to use that zero product property and set the red function equal to 0 and solve for x. So 0 in for f of x. And now we're going to set the factors equal to 0. So one of our factors is x plus 3. And one of our factors is x minus 1. We set them equal to 0 and solve for x. So we subtract 3. So we get an ordered pair of negative 3 up 0. In the green, we'll add 1 to both sides. And we get an ordered pair of 1 comma 0. So we've now found the x-intercepts. Step 2 is to convert this red function to standard form. So we're going to have to FOIL this out first, outside, inside, last. So I'm just going to go ahead and write the function down again. And now we're going to FOIL it. So I'm going to go ahead and put a bracket around here for now and FOIL this blue piece. So first is x times x is x squared. Outside is negative 1x. Inside is 3x. And then last is negative 1. I'm sorry, negative 3. Let's combine those terms inside in the blue. These are my like terms that I'm talking about. Negative 1x plus 3x is 2x. So I'm going to get x squared plus 2x minus 3. Now let's distribute that negative 1 that's out in front of this bracket. So we'll be left with f of x equals, distributing the 1 is negative x squared, negative 2x, and then positive 3. Now we're going to continue the rest of the problem like we did in standard form. We'll start with the axis of symmetry. So we have to identify the A, the B, and the C. So our A value is negative 1, our B value is negative 2, and our C value is 3. We're going to plug it into the axis of symmetry equation. Opposite of B over 2A. So we get x equals negative 2 is a positive 2. 2 times negative 1 is negative 2, and we get negative 1. So our axis of symmetry is that x equals negative 1. Step 2. This is my x value of my vertex. I need to evaluate the function for negative 1. I need to find out what is f of negative 1. So remember, this is my function. I can either use my original function in the red up here, or my blue function down here. It doesn't matter which one. I'm going to just use the blue one. So I have f of x equals negative x squared minus 2x plus 3. So f of negative 1 equals, replace the x with negative 1, replace the x with negative 1, and simplify it. So negative 1 times negative 1 is 1. We still have a negative 1 out in front. then negative 2 times negative 1 is positive 2, and then plus 3. Now we simplify that. Negative 1 plus 2 is 1. 1 plus 3 is 4. So there's now our y value. So our vertex is negative 1, 4. Our c value is our constant. So here's our c value. Our c value is 3. So our y-intercept is 0, 3. Does our graph open up or down? Let's go back up into our blue function here. Notice our a is negative 1. Negative, so that tells us our graph is going to open down this time. And now let's graph it all together. So we'll start with the y-intercept. So we go on the y-axis. Our y-intercept was over 0, up 3. Our vertex is negative 1, 4. And then here in the step 1, our x-intercept, our other x-intercept are negative 3, 0, and 1, 0. Here's negative 3, here's positive 1. We have a point here and a point there. Those are our x-intercepts on the x-axis. Our points are negative 3, 0. Over 1, up 0. Remember, our parabola does open down. There's our parabola. If we wanted to do a line of symmetry, remember that line of symmetry goes right through the x value. The x of symmetry is that x equals negative 1.